Stoichiometry involves the understanding of the relationships among the quantities of the substances in a chemical reaction. In other words, stoichiometry is about the relative amounts of reactants and products in a chemical reaction. When presented in a balanced equation, the quantities of a chemical reaction can be understood in terms of number of moles, mass, number of molecules or atoms, or volume if we're talking about gases. In this video, the focus is on the relationship between number of moles. By the end of it, you will be able to answer questions like, given this equation, how many moles of H2 are required to produce 4 moles of HCl? Once you recognize that this is a question about the ratio of the number of moles of one substance to the number of moles of another, you are well on your way to solving it. You will always be asked to relate two substances at a time. We'll call them A and B. Keep in mind that there are a total of 4 different types of stoichiometry problems. Going from moles of substance A to moles of substance B, which is the topic of this video, is the simplest type. The other type of problems might require going from moles of substance A to grams of substance B, from grams of substance A to moles of substance B, or from grams of substance A to grams of substance B. The last 3, more complicated types of problems will be covered in other videos of my Science Easyfied series. For now, let's look at a sample moles to moles question. Use the following equation to determine the number of moles of carbon dioxide, CO2, that will be produced from 6 moles of methane, CH4. Here you are given 6 moles of methane, CH4, and you need to find the number of moles of carbon dioxide, CO2. In other words, 6 moles of CH4 will produce how many moles of CO2? You determine that you are going from moles to moles. Substance A is CH4 and substance B is CO2. You refer back to the given chemical equation and focus on the 2 substances in question, CH4 and CO2. Going from moles to moles involves a single step. At this point, note that there are 2 ways you can solve the problem. You can either use proportions and formulas, or you can use dimensional analysis. Though I will take you through both methods, the preferred, more straightforward technique is dimensional analysis. I have a Science Easyfied video of a comprehensive review of dimensional analysis. We'll first work through the answer using dimensional analysis. We write down what's given, 6 moles CH4, and then a multiplication sign. This will be followed by a fraction called the molar ratio. To obtain the molar ratio, we refer to the balanced equation and focus on the 2 substances in question and their coefficients. Always remember that when there is no coefficient, it is meant to be 1. From the equation, we see that the stoichiometric relationship, in other words, the molar ratio, is 1 mole of CH4 to 1 mole of CO2. We can write this as 1 mole CH4 is equal to 1 mole CO2. Recall that every equality gives 2 conversion factors. Here, the 2 conversion factors are 1 mole CH4 over 1 mole CO2 and 1 mole CO2 over 1 mole CH4. Which one we use depends on the setup of our dimensional analysis process. In our setup, we started with 6 moles CH4. We will use the conversion factor that has mole CH4 in the denominator in order to cancel the mole CH4 of the starting point. We can see this as a conversion process that changed mole CH4 to mole CO2. We refer to our original plan and note that we have reached our final destination of mole CO2. We write an equal sign, bring over the remaining unit and substance, and do the math. Our answer is 6 mole CO2. 6 moles of methane CH4 will produce 6 moles of carbon dioxide CO2. Next, we'll work through the answer using proportions. We can express the information as a fraction, 6 moles CH4 over X. Then we go to the given chemical equation, focus on the two substances in question, noting the stoichiometry. 1 mole CH4 produces 1 mole CO2. We write it down as an equivalent fraction. Solving for X gives X is equal to 6 moles CO2. Finally, let's compare the two methods and note that they are very similar. But dimensional analysis is more straightforward, more methodical, and requires fewer steps. Now it's your turn to try it. At the prompt, pause the video, think about the answer, then click to resume the video and to check your answer. There will be 7 problems, and I will guide you through the answers of the first 3. Problem 1. Given this equation, how many moles of hydrogen H2 are needed to react with 2.0 moles of nitrogen N2? Let's work through the answer using dimensional analysis. We are given 2.0 moles of N2 and asked to find the number of moles of H2. This establishes that the process will involve a one-step conversion starting with moles and ending with moles. Write down what's given. 2.0 moles N2 followed by a multiplication sign. From the balanced equation, we determine that the appropriate conversion factor is 3 moles H2 over 1 mole N2. Canceling units gives an answer of 6.0 moles H2. Problem 2. Given this equation, how many moles of hydrogen H2 are needed to produce 1.8 moles of ammonia NH3? Establish what's given and what you need to find. The solution starts with what's given, 1.8 mole NH3 followed by a multiplication sign and the conversion factor of 3 mole H2 over 2 mole NH3. This gives 2.7 mole H2. Problem 3. Given this equation, how many moles of nitrogen N2 are needed to produce 3.2 moles of ammonia NH3? We are given 3.2 moles of ammonia NH3 and asked to find the number of moles of nitrogen N2. We write down 3.2 mole NH3 times the conversion factor 1 mole N2 over 2 mole NH3. This gives 1.6 mole N2. Now see if you can try the next 4 without any guidance. Problem 4. Given this equation, how many moles of oxygen O2 are produced by the decomposition of 6.0 moles of potassium chlorate KClO3. Did you get 9.0 mole O2 for the answer? Problem 5. Given this equation, how many moles of hydrogen H2 are produced from the reaction of 3.0 moles of zinc Zn? The answer is 3.0 mole H2. Problem 6. Given this equation, how many moles of oxygen O2 are required to react with 4.0 moles of propane C3H8? The answer is 12.0 mole O2. Problem 7. Given this reaction, how many moles of potassium nitrate KNO3 are produced when 2.5 moles of potassium phosphate K3PO4 react? The answer is 7.5 mole KNO3. This concludes the lesson on using dimensional analysis to solve moles-to-moles stoichiometry problems. Thank you for watching. I hope this video was helpful.